Hi, welcome to the video solution for past paper. This is Edexcel IAL Physics, January 2020, part 1. So let's start. Question number 1. Two waves of wavelength lambda from a single source diverge and then meet again. Which of the following situations would cause constructive interference? So remember, for interference, we have two types of any situation or condition for interference. One is constructive and the other one is destructive. So for constructive, or sometimes we also called it maxima, if path difference is n lambda, then we have a constructive interference. Or other than path difference, sometimes we also look at phase difference or phase. So if waves are in phase, then we also have constructive interference. Similarly, for the second condition is for destructive interference. For destructive, or we also call it minima, we say that if path difference is n plus of half lambda, n plus half of lambda, then we have destructive. Or phase difference is pi, or we sometimes calls multiple of pi, or n pi, something, not multiple of pi, of course, pi, meaning antiphase or out of phase. So if phase difference is pi, not multiple of pi, phase difference is pi, so we call it antiphase or out of phase. Then we have destructive interference. So let's see, the path difference is lambda by 2. No, this is the condition for destructive. A path difference of lambda, indeed. And phase difference of pi by 2, no. And phase difference of pi. So A and D, these are for destructive interference, and part C is for interference but not maxima or minima, intermediate. And this is part B is for constructive interference, so option is B. Question number 2. Which of the following describe the oscillation in polarized wave? A single plane which is perpendicular to the direction of wave travel. So oscillation in a single plane which is perpendicular to the direction of the travel. No, single plane, because it is not perpendicular. Single plane moves along the direction of the travel, or include the direction of the travel. So in many plane, indeed, polarized cannot have many plane, cannot have many direction. Only confusion is we need to understand A and D. So if you see the D is in one direction, oscillation in just one direction, in one plane, and perpendicular to the direction of travel. So option is, of course, D, that include the direction of travel. Question number 3. Which row in table shows total resistance of two 5 ohm resistors are connected in series and parallel? So remember, if two resistors of same magnitude are connected in series, so resistance will be double. So you say that if 5 ohm resistors are connected in series, something like this. These are 5 ohm resistors connected in series. So the total resistance would be double. So in series, it will be 5 plus 5, 10. So series, it cannot be 2.5, 2.5. So option is either C or maybe D. And if two resistors of same magnitude are connected parallel, remember, if two resistors of same magnitude are connected parallel, then total resistance becomes half. halved. So 5 of 5, so half is 2.5. So parallel, it is 2.5. So option is D. Like if I say this is 3 and this is 3, both are in parallel, so the net resistance will be 1.5, half of uh, the value of the resistor of each resistor. Question number 4, the current potential difference graph for an ideal diode is shown. The graph has been labeled at 3 separate points by the letters X, Y, and Z. This is diode graph, a typical ideal diode graph. Okay, so potential difference and current. At which points is the resistance of this diode infinite? Remember, if resistance is infinite, then there is no current passes through the diode. So we see that at point X and at point Y, these 2 points have no current, zero current. That means at these points we have infinite resistance. So your option is A, X and Y. Question number 5, a copper wire has a cross-sectional area of 5 10 to the power minus 7. There is a current in the wire of 0.93 ampere. Copper has 8.4 10 to the power 28 conduction electrons per meter cubed. Which of the following gives the magnitude of drift velocity V in meter per second for the conduction electron in the wire? So it's a straightforward question. Only thing that you need to understand is the equation or transport equation that link drift velocity V and current and area and these kinds of stuff. And the transport equation is I is equal to N A Q V, where Q is the charge. So in place of Q, I'm using electron. So this equation becomes N A E V. We just rearrange for drift velocity. So drift velocity V would be equal to I divided by N A E. So I is the current, which is 0.93. Definitely I should be numerator, so immediately you can ignore B and C. So either A or D. So of course NAE. This is your A area. This is your N, charge carrier density, number of electrons per unit volume, and E is the charge of electron. So you see that this is your I, this is your N, and this is E and A. Clearly it is B. Question number 6, when the photoelectric effect occurs, light incident on the surface of metal releases electron. Which of the following is an experimental observation of the photoelectric effect? Electrons are only released after light has been incident for a long time. No, electrons are emitted instantaneously as soon as the photon just hit. So no, it cannot be A. Increasing the frequency of the light, increasing the maximum kinetic energy. Indeed, it should be B. So your option must be B, because if you increase the frequency, then kinetic energy or maximum kinetic energy of emitted electrons are also increased. So increasing intensity of, but for the we just see the C's. Increasing intensity of the light, increasing maximum. There is no relation between intensity and the kinetic energy. There is no effect of increasing intensity on energy. Increasing intensity only cause increasing current, because more electrons are emitted due to increasing number of photon. Only light with the wavelength above a threshold value releases electron. There is no relation of wavelength. There is a relation of frequency with the threshold value. So of course the only option is B. Question number 7, a negative temperature coefficient thermistor is connected in a circuit as shown. This is thermistor, some resistor V1 V2. The temperature of the thermistor is increased. Which row of the table shows how the reading on meter V1, V2 and A changes? Clearly we know that thermistor, for thermistor, if temperature is increased, so the resistance of the thermistor is decreased. causing more electron to flow. So if temperature is increasing, resistance decreasing, clearly voltage should decrease because resistance decreasing. So voltage across thermistor should decrease, which is V1. If you see V1 column is there, so A and B, these two are your option. You need to choose. You can ignore C and D, don't waste your time. A and B. So if V1 is decreasing, so V2 should be increased. So decrease and increase. So clearly it's option A, but again A, because current is increasing, so in both current is increasing because number of electrons are increased. So option is A. Question number 8. Waves may be longitudinal or transverse. Which of the following statements is correct? All transverse waves travel at the same speed. No, it is not necessary. Only electromagnetic waves which are transverse, they travel with the same speed. Otherwise, transverse waves in water, they move with different speeds. All transverse waves have a vibration that are parallel to the direction. No, this is definition of longitudinal, not the transverse. Both transverse wave and longitudinal waves can be refracted. Indeed, it should be, option should be C. No transverse wave can travel through liquid. No, there are transverse waves that can travel through the liquid. So option is C. Question number 9. In an experiment, laser light is shown through a diffraction grating so that a series of bright dots appear on the screen. The equation n lambda is equal to d sine theta can be used to determine the wavelength of the laser light. Which of the following is a correct description of how experiment should be performed? The angle theta is measured using protractor. No, there is no restriction about measurement of theta because theta is very small, so we cannot use protractor. The diffraction grating is set up so that it is parallel to the laser beam light. No, if diffraction grating is parallel, then light will not pass through the grating, so it cannot be option B. The diffraction grating set up so that is parallel to the screen. Indeed, it should be C, because the diffraction grating, which is, you can imagine, this is the grating, and grating is something, you have a line, grating line here, something like this, so it should be parallel to the screen. So when light pass through the grating, then you know that it hits and produce a pattern. So option should be C. The distance between the bright dot are measured. There's nothing to do with the options D as well, so option is C. The evidence for the wave nature of electrons came from experiment involving a typical question of wave nature of electron. It's all about diffraction of electron, and hence evidence of wave nature of electron. So option should be A. Question number 11. An experiment is carried out to investigate the speed of transverse wave on a string of length L. A vibration generator causes the string to oscillate so that a stationary wave is produced. The frequency of the vibration generator is adjusted until the wave pattern shown in the diagram is produced. Okay, so this is a typical standard question of string of stationary waves producing through a vibration generator. Number of loops, string length L. Okay, so determine the wavelength of the wave on the string when vibration as shown. So from the diagram we have these number of waves and the loop, so we need to find the wavelength. Clearly, if you see, you need to count how many loops do we have, or in terms of wavelength. So you know that from one node to another node, this distance is called half of the wavelength, lambda by 2. And how many loops do we have? 1 2 3 4. So we have 4 lambda by 2. So we say that we have 2 lambda. Also you can see that in a way that you have two waves. So this is one wave here, and we have second wave, so total 2 waves. So 2 lambda is a total length in terms of wavelength. So you say that 2 lambda is equal to the length L, which is 1.7 meter. So lambda is equal to 1.7 divided by 2, so 0.85 meter. This is the wavelength of that wave. Calculate the speed of a wave on the string. Mass hanged is 0.2 kg. Mass per unit length of the string is this. So remember, mass per unit length, this is your mu, and in your formula sheet you will be looking at a formula of that particular case. So speed of the wave in this case, v is T by mu, where T is the tension in the string and tension is due to hanging mass. So you can say that this is T is mg divided by mu. So you just plugging all the values, and m is 0.2 times 9.81 divided by mu is 4.5, 10 to the power minus 3 square root. So your velocity would be equal to 20.88, or you can say 20.988 or 20.9 meter per second. This is your speed. The frequency of the vibration generator is reduced until the wave pattern shown below is produced. So frequency is changed, so pattern is changed. Before we had 4 loops, now we have 2 loops, so pattern is changed. Explain the effect that this would be that this would have on the speed of the wave on this string. Clearly, if you see, what are they doing? They are just changing frequency. See, they are changing frequency. Now if you see the relation of speed v depends on only the hanging mass or tension in the string and the mass per unit length, and in this case both are stays the same, so they are not changing. So speed does not change because the speed depends on these two factors. So speed remains the same. Question number 12. Solar panels generate electricity when sunlight is incident on the surface of the panel. The total energy, the total generation of electricity worldwide in the year 2014 was approximately 23,800 terawatt hour, and 1 terawatt hour equals 3.6 10 to the power 15 joule. Some scientists claim that if the Sahara Desert were covered with solar panels, sufficient electricity could be generated to supply the whole world. Calculate the maximum energy received by the solar panels in 1 hour. Okay, we need to find energy in 1 hour. Maximum intensity of the solar radiation at the Earth's surface is 1100 watt per meter square. This is your intensity I, and area of the desert. So it's a simple question. You know that the relation between intensity, power, and area. So intensity is power upon area. So you can find power here. So power is equal to intensity into area. Just multiply intensity 1100 times area 9.2, 10 to the power 12. So P would be equal to 1.012 into 10 to the power 16 watt. This is power, and you need to find maximum energy. So maximum energy E is power into time in 1 hour. So power is 1.012 10 to the power 16 times 3600. 1 day, sorry, not 1 day, I'm sorry, 1 hour 3600. So energy is 3.64 or 3.6 10 to the power 19 joule. This is the amount of energy produced if Sahara Desert is covered in this area in 1 hour. Determine whether covering the Sahara Desert with solar panels would be able to generate enough electricity for the whole world. So we just need to compare energy produced by Sahara Desert in 1 day or maybe 1 hour with the given value. So what I'm going to do is, since 1 terawatt hour is equal to 3.6 into 10 to the power 15 joule. So for that much joule energy, produce 1 terawatt hour energy. So how much energy did we calculate from Sahara Desert in 1 hour? We calculated energy is 3.6 10 to the power 19 joule. So how much energy is produced? You just cross multiply. When you cross multiply, you will find that it will be 10,000 10 to the power 4 terawatt hour. So this is energy produced just in 1 hour. So in 2014 data, we have 23,800 terawatt hour. So how much time do we need? Again, X, just question mark. Then you see that if you do again cross multiplication, so your X would be equal to 2.3 hour. 2.3 hours, so approximately 2.5. So it is less than 3 hours. So of course you say that the required electricity is generated is less than 3 hours or around in 2.5 hours. So indeed it will work. Sandstorms are common in Sahara Desert. Explain why sandstorm reduce the power generated by solar panel. Of course, due to sandstorm, there will be a lot of sand over the panel. It will cover the panel. So light intensity will decrease. So intensity decrease. So less number of electrons emitted. Current decrease. Of course, efficiency is also decrease. Question number 13. A pulse echo technique using ultrasound can be used to produce images of an unborn baby as shown. Explain how the ultrasound scan of unborn baby is produced. So producing image through pulse echo technique can be understood if you know what pulse and echoes are. So if you have some device, generally this device is called transducer, and we have some obstacle in front of the transducer. So what happened, this transducer emits some wave, like generally ultrasound wave, moves and go towards the obstacle, and then after hitting the obstacle it just return or reflect as an echo. So this is the pulse that you are the wave that you are sending, it is called pulse, and after reflecting what is coming is called echo. So you know that a pulse is sent and an echo is also received, and the time difference between the the sent one and the received pulse is noted or is recorded by this transducer, so time is known. And of course velocity or speed of this sound wave is also known. These two are known speed and time is measured, and the total distance covered by pulse or the send and the received is this distance, which is s, but this is not s, this is 2d if the distance is d. So just you say it is 2d, leave it, otherwise you will confused. So the total distance is d plus d, or 2d. Now you can use a general equation of motion, s is equal to ut, but in this case this s should be 2d is equal to ut, and then d can be found, d is equal to ut by 2. So if distance is found, then we just move over the surface, and then we can have a different distances, so image can be found using measured distance. Question number 14. Photocells make use of photoelectric effect. The following circuit can be used to determine the work function of a metal used in photocell. So incident light, photocell, variable power supply. Okay, typical circuit of photoelectric effect. State what is meant by work function of the metal. So work function means amount of energy, minimum amount of energy that requires to emit electron from some metal surface. So that's how you defined the work function. This photocell works with ultraviolet light but does not work with visible light. Indeed, if it is working with ultraviolet light, that means the frequency of the ultraviolet light is greater than the visible light, and also the frequency is greater than the threshold frequency that is needed to emit the electron. That's why ultraviolet works in this particular case. Part C. An experiment was carried out using the circuit. The potential difference applied to the photocell opposed the movement of the electrons through the photocell, reducing the current. The variable power supply was initially set at 0, and the reading on the ammeter was 2.4 microampere. The intensity of ultraviolet light was then increased without changing the frequency. Explain what happens to the reading on the ammeter. Clearly, we have a relation between intensity and the amount of current, because intensity is increased. That causes number of photons arriving or reaching at the surface, number of photons to increase. So more photons hitting the surface, and that they will collide with more electrons, so number of electrons emitted from the surface increase. So that means overall effect is current is increased. So increasing intensity, more electron, more photon, more electron, so current increase. The variable power supply was adjusted until the reading on ampere meter becomes 0. The reading on the voltmeter was 3.59 volt. Calculate the work function in joules. The metal used in the photocell work function. Okay, frequency of the ultraviolet is 2 × 10⁻15 hertz. So you know that the equation for the photoelectric effect is HF, energy of incident photon, is equal to work function plus maximum kinetic energy or kinetic energy gained by the electron, EK. And as they are saying that the power supply is adjusted so that there is no current, that means this EK is equal to VE, where V is the voltage and E is the charge of electron. So we can replace EK with VE. So HF is equal to phi plus VE. And now we need to find phi. So phi is equal to HF minus VE. Now we have everything. We just substitute and we can figure out phi. Phi H is Planck's constant 6.63, 10 to the power minus 34 joule second. Frequency is 2 into 10 to the power 15, which is there. This is frequency. Minus V is the voltage, 3.59, times E is the charge of electron, 1.6, 10 to the power minus 19 coulomb. When you solve this, so phi would be equal to 7.556 or 7.6, 10 to the power minus 19 joule, and calculate the work function in joule. So okay, so this is your final answer. Question number 15. A water wave approaches a boundary between deep water and shallow water and is refracted. The direction shown how the direction of travel of wave changes. Deep to shallow, incident angle, refracted angle. Explain why the wave is refracted as shown as it travels from deep water into shallow water. You may add to the diagram if you wish. Okay, so the reason is when the wave is traveling in a deep water, it has high speed. As soon as it starts entering into the shallow water, so in shallow water speed is decreased. So you say that here you have a high speed and here it is moving more slowly or less speed. So what happened when suppose it's just the case, I'm just explaining, this is a situation. So this is the one of the wavefront. This wavefront has two part. One is in the deep water, which is moving faster, and this one is in the shallow water. This part is in the shallow water, so it is moving with the less speed. And now in order to compensate the motion, this wavefront which is in the shallow water bends something like this, and then it moves forward. So that's how, in order to compensate the speed, because the one part of the wavefront is in the shallow water and the other part is in the deep water, moving with a high speed. So that's why it changes its direction. Part B. When waves travel across the surface of water, their speed v is dependent on the depth d of the water and the wavelength lambda of the wave. For waves traveling in deep water, where d is greater than lambda by 2, v is equal to square root of g lambda by 2 pi, and for wave traveling in shallow water, v equal to square root of g into d. Calculate the angle of refraction r. Wavelength of the wave in deep water is 15, depth of the water is 10, depth of the shallow water is 0.5, angle of incidence is 40. So the idea is we have two formulae. N is equal to sine I over sine r, and also we have N is equal to V1 upon V2. So this is for rare to denser, or deep to shallow and deep to shallow. So we have a deep above and shallow down in both the equation. So speed of wave in a deep and speed of wave in shallow water, V2. So the idea, we can compare these two because we don't need N, we need R. So we can compare and we can rewrite this equation as sine I divided by sine R is equal to V1 upon V2, something like this. And then when you substitute the value V1 and V2, so this is your V1 and this is your V2. So sine I divided by sine R is equal to V1. V1 is G lambda by 2 pi square root. This is your V1 divided by V2. V2 is GD square root. This is GD. So we can rearrange for R. So sine R, and you can cancel G and G. If you just simplify this equation, so I am just writing directly. So sine R would be equal to 2 pi d by lambda square root into sine of I. Now you can see that you have everything to find R. So when you plug in all the numbers, so 2 into 3.14, D is the depth, and this D is all about the shallow water. So shallow water depth is 0.5. Don't be confused with this depth of the deep. Don't take 10, it is 0.5. So 0.5 divided by wavelength, which is 15 meter, under root sine of 40. So sine of R would be equal to 0.294, and R will be sine inverse, so 17.1 or 17 degree. This is your angle of refraction. In 1933, the crew of the US Navy ship USS Rampo took measurement from one of the largest waves ever recorded. The wavelength of the wave was 342 meter and the time period was 14.8 seconds. Show that depth of the water where the crew measured the wave was greater than 170 meter. So the idea is we need to figure out the wave of this speed with given number and compare this speed with the speed of the shallow or the depth. So you can say that first you find the measure speed. So since V is f lambda, or you can say it is 1 upon t into lambda, because frequency is not given, time period is given. So lambda divided by t. So V is equal to, or it's better if I say V naught, observed, just to differentiate the comparison. So V naught is observed speed. If you wish, you can say that the observed speed, if you wish, observed speed. So V naught is f1 upon t lambda. Lambda is 342 divided by t. T is 14.8. So V naught would be equal to 23.1 meter per second. This is the observed speed. And now let's calculate for deep water. For deep water measurement, you know that V is deep water. So V is G lambda by 2 pi. So G is 9.81 times 342 divided by 2 pi. 2 pi is 2 pi. calculator. So we will give you 23.09. Clearly 23.1 meter per second. That means measurement was made for the deep water. So you can say that the crew was at the deep water, because D is, for deep water, D should be greater than lambda by 2. Or if you say that it is lambda is 342, so 342 divided by 2, which is of course greater than 170. So that's how you can say that indeed the crew was at the deep water. So depth should be greater than 170. Thank you very much. I hope you understand. Have a nice time.